So guys, basically these are NumPy or pandas or whatever it is. These are packages. These are modules which contain some program that helps developers to like speed up the development process. Like there are things that you don't have to code like from scratch. That's why we have these things about the libraries or a frameworks or such things. So there are something that are already implemented. So the developers they just import the files and then use it in their development process. So first of all, I think let me first of all show you, for example, how you can use a module. Now, basically, a module is like a library of code library. So for example, you want to make your program so clean or a symbol, you can write some program somewhere in a different file, and then you just use it a specific part that you want to use it. Instead of writing a bunch of code in a single file, you can write in a separate files, and then you just use specific parts where you want of whichever the files that you only want to use. Now, I think I can, let me just create here a file. I show you how, for example, you can create a module, and then you'll be able now to understand how these other modules, these big packages, libraries like a NumPy works. So let me let me uh, let me create a folder somewhere. How do I create the folder? New, then a folder. Let me call it NumPy. Now, when you are creating a module, it must be a real or a normal Python file, not the Jupyter file. It should end with the extension py. So, for example, let's call it. I can call it a module like. Let me just call it something like. Let me call it module.py. So it must end with this extension.py to show that it's a Python file. And then we can try like creating anything in this function in this Python file to create our module here, and then we shall use it. So let me just define here anything like let me use even a greeting a function greetings, and then here I'll pass in some arguments. For example, I can say, for example, let me just say L name for F name. Then the other can be L name for last name. For L name. Now let me return here return. I'll use a formatted string here. Let me just say hello there. My name is and then the white space. Then here I'll pass here the first name. Can I use Wekesa Nehemiah? Let me try L name to begin, and then a white space. The white space, they help you like to have separation within the names, so that the names cannot be like close to each other. So my name is L name, and then L name, and then what's first name, F name. So I want to use a Jupyter notebook because I think that is much easier to illustrate or to work with it, or to teach, or maybe for discussion purposes. It's quite easier. So I believe we are together. You can just unmute and let me know if you're on board or you are sleeping, because today I think it's Friday. People are in the party and they have just signed in their presence. They have just shown in, but they are not there. So those who are present can just unmute and say we are together, something like that. Okay, thank you. Yeah, so you ensure that if you don't want to like type the absolute path, you ensure that the file that you're using on your program, it is in the same file where you have the module, so that you may not encounter errors. So I'll open the Jupyter notebook, and basically this is how you can use that. This is how you can use that module or a library of code. So you can say, for example, you first of all begin by importing. Call it NumPy. So you'll first of all begin by importing that module. Remember, they are in the same directory. When you refresh, let me refresh here. You can see they are in the same directory. So we are not like struggling to like ensure that it is in the same directory so that you may not encounter any issue. NumPy. And then now, so to import the module, you just say import. You use the import keyword. Remember, import is a preserved keyword in Python. You cannot use a import statement as a variable. There are some things there are some keywords in Python which are preserved. For Python, you can't use them. Like these things, so like when you just type import and then you see it is green in notebook, just know that is a preserved keyword in Python. And then so you use this import to import the modules, and then the module name is module.py. So you just say module because it's Python already. So just say module. I think the spelling is correct, I believe. So this is how you import the module. And then let's say, let me just say, let me use a variable, for example, let me say something like a result. I'll assign there to module, and then the function name. So here to define a function, you're gonna use you're going just to type the nini itself. I don't know which function I used there. Let me just greetings here. So the first the first argument, the first parameter there defines the module, and then the second parameter defines what the function that you want to use. So, because I created a greeting message where it's gonna have the first and the last name. So I'm gonna say actually the arguments that I'm gonna pass there are, so I think it began with the first and last. I don't know. So let me just say I don't know. Is it Nehemiah first? I'm not sure. Let me just confirm. I began with the first name, first name. So let me use Nehemiah. Or any other person who want me to use their name? Yeah. You want to be a celeb? You want to be a celeb? I can use your name. It is
Anthony.
Ray, and the last name
Anthony.
Anthony. Okay. I hope I brought the correct name. And then let's do it. Let's print the result. Print should be a result. Yeah. So let's run. And then now you can see we have hello there. My name is Anthony Ray. So like you can see, we've avoided some other codes there that are in this other file. So we've just called that function, and then it has returned what the result. So basically this is how modules work. So you can have things that solve a particular problem. So they are located in a particular file or a package, so that instead of writing a bunch of code from scratch, you are going to use those things that they are already like implemented. So your task is just to use them. So and one of the modules that we are going to discuss are a package. You remember now when you have several modules inside a particular directory, you'll call them like a package or a code library. It consists of several packages. So like a NumPy, for instance, it has a lot of modules inside that package. inside that package. So you can use other modules inside the NumPy. And so basically this is how it works. You first of all begin by importing. So this one is a Python framework. So you have to install like this one, because we've code manual here. We are going to like place it in the same directory. But now NumPy is a Python package you have to install, or something like SciPy or maybe Pandas. Those are Python packages. So for you to be able to use them, you're going to install it so that it will go to the Python system, and then you'll be able like you'll be able to import and use the functions within the NumPy. Within the NumPy. So we are not like having the folder for NumPy here and then importing it. We are going to like download and then use it. So first of all, let's understand what is NumPy. NumPy stands for the numerical Python, and it is a library used, or maybe a library that works well with the arrays. Now I know most of the time we were used to Python list, but now we are introducing another aspect or a data structure called the arrays. So basically this one is I can simply say it has the function for working with or within the domain of linear algebra. Also, there are something that we shall also talk about called the Fourier transform, and then the matrices. So now, basically, this NumPy is always faster. It is always faster compared to our normal Python list. I think I'll show you later. When you do a research, you'll find out that it's kind of even more than 50 times faster than our normal Python list. Now, the disadvantage about this NumPy, it only works with, uh, you know, it is, how can I, it is homogeneous, or maybe, let me put it this way, it only allows you to work with like the same data type. You can, same data type. You can't use, different. For example, if you've decided to use the strings, it will be just strings. If you've decided to use, you know, other like integers, it will be just integers. You can't use several data types at the same, at the same one. Unlike pandas, pandas is a package which is built from NumPy, but now for pandas, it allows you to like work with, several, data type. It is heterogeneous. So basically, how do you import, a NumPy? So to import NumPy in the system, remember we always use the PIP, and I think I've told you, I've repeated this thing several times, that a PIP is a package manager to install the Python modules. So for example, if you want to install it in the system wide, you can just run the PIP in your command line interface. It is CMD. Let me just search for CMD. So just type there pip install what? NumPy. Is that the spelling for NumPy? Yeah, I think that's the spelling for NumPy. I think for me I already have it, but basically when you run that command, it will, I don't have, it will download for you. Alternatively, you can install in your environment. If you're using Anaconda, you can just go to Anaconda, and then you go to the environments, then you'll search for the NumPy, and then you'll install. But because my computer usually take time to load Anaconda, I'm not going to that direction unless someone wants assistance on that, how to install it on Anaconda. Anyone with an issue on installing it in Anaconda? Hmm? You are good?
Yes. Yeah.
Oh, wonderful. All right. So now, so this way, you will have installed this this is NumPy inside inside the Python. Pardon? All right. I believe I don't know if it's a question or a. So I heard someone talking. Yeah. So is someone talking?
You can just proceed, Mama. I don't know who it was, but they're muted.
Yeah. So in case someone has an issue, can they can just talk. Yeah. So basically now, because we've installed NumPy inside Python, we don't have to download a folder and then use it the way we use it in our local module here. This one is a package, so when you download it that way, it will come inside the Python, and then I will just be able to use it direct. So you just say import. Remember, import statement used to import all packages, all libraries. So import NumPy. You can say import NumPy, and then let's create an array. So to create an array, let me use just a variable called array, and then I'll assign here to NumPy. NumPy defining you remember the way we used here. You first of all begin by defining the the module, and then followed by the function that you want to use. So here it is gonna be NumPy to define the module, and then now here is the array function that we are gonna use here to create that NumPy array. So basically the array, it is defined this way, or maybe you understand how you use the methods or a function in Python. They must be inside these two parentheses. But now here you'll add in these are list. These are lists, the normal list. It is similar to the normal list. The only difference is that this one only carry a particular data type, doesn't contain several other data type. It is homogeneous, if that's the correct term to use. So let me say 1 2, and let me say 1 2 3 4 5, and then let's print. What are we printing? Array. Sorry. Okay. Yeah. So you can see, guys. But now there's also you can have a particular module which is long, which is a long name. And for example, if you are like me, you don't want to type a lot or to use a long names, you can use an alias. So for example, if you just want to use this NumPy with just a single word, a single letter, you can as well do this. Let me just copy this code. If you want to use an alias for this NumPy, assuming that it were a long name, you want to use an alias of these things, you can just say, for example, P. But now when you say P, you'll have also to change it here to P. So this is, no, you have to add in the AS keyword first of all to define that you're using this P as an alias for NumPy. So you say AS. So AS also is a preserved keyword in Python. You can't use that one as a variable. So you can see it changes the color. I don't know if you're able to see. Let me zoom in further. Yeah. So this way you'll be able to, let me change the values here so that you see it works. Let me say 6 and so forth. Yeah. So you can see it is working. But now when you read the NumPy documentation, in their alias they used NP. It's a good practice to use their default one for NumPy, but you can use any other. But when you use NP, I think people will understand you, because this one is what is available in the NumPy documentation. Yeah, so basically this is how you do it. Now, first of all, how do you check the version of NumPy you are using? So first of all, when you are working with NumPy, you must begin with importing this thing. Now remember, this one can't work because I've used it as an alias, but okay. I don't know why it's working, but once you're using here an alias, you should as well use it here, NP, for it to work. Yeah, for it to work, to work well. Now, how do we check the version of NumPy you're using? Now, because this one is going to on YouTube, now by the time we are doing this video, I think the version will be this one, NP. Remember, this NP is these are layers. But if you were to use just a normal NumPy, you could write here NumPy instead of NP. Alias is like a nickname of something. Like let's say, um, like for example, yeah, a good example is like for example, the president of Kenya is William Ruto, but the alias or the nickname of the president, they usually call him Zakayo. So Zakayo is a nickname for it refers to the same person, William Ruto. So basically, alias work the same way here. So NumPy, when you say NP is like a nickname for NumPy, they all refer to the same thing. I believe you people are understanding these things.
Yes, Nehemiah, we are understanding.
Wonderful, wonderful, kabisa. So
And you need to tell us where you were the past 1 week, because it's like you're speaking Texas English, eh? We're gonna import.
sorry for that.
No, it's actually in order. That's what we need.
Oh, okay. Yeah, I've just arrived from the US, and that's why. Yeah. So by the time we are recording the video, the version is 1.26.3 of a NumPy. So basically, this is how you check the version. So I think we are together. We are proceeding well. Now, basically NumPy, I said that is used to work with the arrays. The array object in NumPy is called ND array. So we create a NumPy ND array object by using this array. Let me just copy this part, and then I'll use it here. So basically, this is how you create an ND array object. You use basically this function. Remember, a function in Python should have the parentheses, these parentheses here. So we can check the type. So by using this function, you'll have created this NumPy array object called ND array. Let me just show you how it is. So let me say print then type, and then we are passing array. And then you'll see that it will be ND array. As you can see here, it is ND array. So basically, we use this array to define what the NumPy array object, which is ND array object. Remember, these are type that I've used here, just like what we used in the other data structure the other time. We use this type. This type is a built-in Python function which tells us the type of the object that is passed into it. So like in our case here, it shows that the object here is an ND array object. Yeah, so basically this is how you like create a NumPy array object. But now the key thing about, you had me the other time, I was more into like a dimensional array. For example, the time where we had the nested loops, I used to talk to you about for example, one dimensional, two dimensional, three dimensional. So basically, the NumPy works well with these dimensions. So whenever you heard about you're working, for example, with for example, a one-dimensional array, two-dimensional array, so that is part of the NumPy array. So this is the goodness of the NumPy. So a dimension in an array is like a one level array depth, or let me put it this way, the nested arrays. So for example, you have a list. The way we created the nested list the other time, you have a list, and then you have another level of another list inside a list. So that's how you create these arrays, or basically the nested array. So basically, nested array, these are the arrays that have arrays as their elements. So let me show you, for example, how to create a two-dimensional, a zero-dimensional array. So for a zero-dimensional array, let me just use this thing. For a zero-dimensional array, is like this one. This thing here is a zero-dimensional array. We don't have a nested array in it. It's just like that. But let me use another one. I remember I'm using this thing to refer to array because I don't want to write long names. NP. Remember?
Nehemiah, sorry for cutting you short.
Yes, yes.
I just wanted to inquire if you had initially imported NumPy on the previous cell. Do you need
Cell.
again to?
Actually,
Do you need
I'm
again
trying.
to? Sorry.
I'm trying to repeat these things so that people can understand maybe. But now, because we are in the same notebook, once you import it here at the top, you can still use it there at the bottom. But I'm trying to show everything step by step, so that people can understand how to use it. There's no harm still, even if you re-import. But now, for the sake of teaching, I want people understand everything, what everything is needed there.
Yeah. Okay. Thank you.
Yeah. But guys, I remember that we are using the same file. We are using the same Jupyter notebook. But now, because I'm teaching, or we are discussing here, I want to illustrate everything in each set, so that you can understand these things. But once you've mastered, you can just import it there. In fact, the first line can be just for importing the module, and then the rest will be for coding. But now, because we are teaching, I'm using it I'm repeating myself, so that I want people to understand everything. Everything. Yeah. So let's create our array object. And we said, what is our array object inside this Python that we create with this nd array, with this oh, by the way, guys, I talked about the one-dimensional array. Guys, I think I misled you. So this one is a one-dimensional array. This one is not a zero-dimension array. This is a one-dimension array. So for a zero-dimension array, it doesn't have any array elements. It doesn't have anything. It just have, for example, if it's an integer, you can say something like 100. So basically, this is an example of a zero-dimensional array. So basically, a zero D, sometimes it's called D. One dimensional, they call it D. So for example, you heard of a 3D screen, or a 1D, or a 2D. So basically, that D stands for dimension. Whenever I say D, for example, 1D, 0D, I mean the dimension. So for a 0D, or a zero-dimensional array, or maybe a scalar, these are the elements in an array. These are the elements in an array, and each value in an array is a zero D array. So basically, this is how you create it. And then when you print what r. So basically, this is an example of zero-dimensional array. And then now one-dimensional arrays like this one. Let me just copy somewhere. Yeah, here it is. Should I be adding the markdown? I don't know if create cell above. There was that option to create a cell. Oh, here it is, I think. Insert cell below. I want to insert the cell above. Alright, let me shift this one to go to the bottom, and then this one to go to there. So let me say 0. 0D, I mean 0 dimension array. Markdown. Let me use it's too big. And then so we are going to the one-dimensional array. So I think once you understand the structures of these things, you'll be able to understand how to work with this array. So let me just say here 1D array. This one is a code, and I was trying should be a markdown. So a 1D array. So basically an array that has 0 dimension arrays as its element is called a unidimensional array, or a 1D. So basically a 1D it has a 0 dimension array inside it. So when we talk about 0 dimension arrays, like when you just have the values, we don't have a list. You can see this is a 0 dimensional array. We don't have these things here, like this list. So it doesn't have this thing array. It is just like that. So this is a 0. Now for a 1-dimensional array, it contains this 0 dimensional array as its element, there's its element. So and this is the example I thought I had copied. Let me just copy. So so this is an example of a 1-dimensional array. So you can see it is an array element, but it contains a 0-dimensional 0D is its element. Like you can see, this is the first 0D, another. So this is like a 1-dimensional array. It is an array that contains 0-dimensional array as its element. So so this is an example of a 1D array. Let me now show you an example of a 2D. For example, an example of a 2D array. 2D array. Yeah, so basically a 2D array is an array where that contains 1-dimensional array as its element. Like we saw, 1-dimensional array, it had 0-dimension array as its element. But now for 2-dimensional array contains 1D array as its element, as its elements. So now let me do this. Let me copy. Yeah, so basically this is a 1-dimensional array, but we said it is an array that contains. So basically an array list, we define it with these the way you define the list. They are just similar like the list. Now the difference here is that I told you the difference. Don't have to repeat it again. So it's just a normal list, but now it contains other elements as its element. It contains 1-dimensional array as its element. So you can have that 1-dimensional array. So this is the first 1-dimensional array, and then you can have another. I think I can just change the values. But let me use 1, 2, 3, 4, and then here I'll continue to what? To should be 5, 6, 7, 8, 8 and 9, right? It should be 8. Now 5 8, it should reach 8. So you can see for a 2-dimensional array is an array element that has 1-dimensional array as its element. So you can see it is an array element, but it contains 1-dimensional array as its element. Guys, are you understanding?
Yes.
And basically this one I used to represent the matrices, the matrix or the second order tensors. I think we shall talk about those things perhaps in future. So let me first of all run it. So basically you can see it is a list. So basically this is how you define a list, an array. So you can see we have the outer array, but now it contains like a list. Other array element is its element. So it contains one dimensional array is its element. So I'm going to show you the last one, the third, but you'll understand how it goes. So for example, for 3D, it will contain, someone can guess that one. Someone who wants to try that. What is a 3D?
It will contain 3 lists.
3 list? No. You are in the right track. You can try again.
Okay, this is how I think it might be, let's say, an easier way to remember.
Mm-hmm.
Like for instance, if you want to know that an
Who is
array is
talking?
a
Who is talking?
one-dimensional array, it simply contains one list.
Mm-hmm.
Two-dimensional arrays contain 2 lists. It's actually a list of lists. Three-dimensional arrays, a list of list of list.
Yeah, so now to put it in a professional way, you can just simply say a thread is an array that contains two-dimensional array as its element. So you can see the way these things are. So you'll use it the way it is. Like this thing will be like the element. It will be like the first element of the 3D. Let me copy it in the, because when you say like you are correct. By the way, you are correct. I forgot to congratulate for saying it in a correct way. So you are just right. Now for 3D, to put it in symbol terms, symbol words, based on the flow that we had, it is an array. It is an array that contains the two-dimensional array as its element. So you can have the first two-dimensional array, comma, and then you can add in as many as you want. You can have even 4. You can have even 4. So this is an example of a 3D array. So it is an array that contains 2D array as its element. So it can be one element, it can be 2, 3, 4, or to infinity. So it doesn't like so these dimensional levels, they are not defined with the number of elements. Now the number of lists here, like a list 1, list 2, list 3, that's not how you define those dimensional. It is like it's like you can just simply put it is for example, if it's a two-dimensional array, you can just say it's an array that contains the elements of that contains one dimensional array as its element, yeah, to put it in a symbol. Well, so in that the process continues. You can try four-dimensional. It can go to infinity. But guys, I believe you understand now the flow here.
Repeat that part again.
Kidogo to just a minute, guys. Pardon your question, Ray. Is it Ray or Andrew?
Just repeat. You should just repeat the three D array again.
I'm just hearing the dog. The dog. You can repeat the question, or someone who has heard can inform me. Is he saying that I repeat, or I had something like that?
Yes, he said you repeat.
On what? On these are arrays, or where specifically?
It seems like Ray's dog has stolen his meat. Maybe.
Oh, but let's just assume that he was asking that I repeat on these three, though I'm not sure. Let me just try to repeat. So the process begins from the zero-dimensional array. So for a 0D array, a 0D array is like a 0D array. How can I put it? A 0D array is like as an array. A 0D array is an array that contains like a scalars. Contains just single values as its element. Like this is an example for 0D. It just contains these scalar values, uh, of which are its element. Contain just these things as its element. So this will be like a zero-dimensional array. But now, when you want to define a two-dimensional array, it's like an array element where it contains a zero-dimensional array as its element. So you can see now on this one-dimensional array is containing these scalar values as its element. You can see we have if it were 100, 200, and so forth, it will be like the values on a 0D array. So it contains the values of the zero-dimensional array as its element. Now, when you go to the two-dimensional array, is an array list. So you know that whenever you have a list or a array, remember I told you that array, these are just like the list, normal lists, which are defined with these square brackets. So when you say that an array that contains other arrays, it means that you first of all begin with this two square bracket to define that it is an array. But now it contains the one-dimensional array as its element. So you can see this is the outer. So this is the outer what? This is the outer list. But now inside it, you are going to have this one-dimensional array as its element. This way, you can have the first one-dimensional array, and then another one-dimensional array. So you can have as many as you want, provided that they are in this level. Let me just try to do that. They are separated with a comma. Remember, parameters are separated with a comma like that. So this is an example of one two-dimensional array. It contains one-dimensional array as its element. Now, when you go to the 3D array, 3D array elements, it contains 2D. It contains now this 2D as its elements. It contains two-dimensional array as its element. So you remember the structure. Let me zoom out a bit so that I can see this. So you can see, let me just simply put it, let me just make it simple. So you can see, so basically this is how you define what, where was I? So basically this is how you define an array element. But now, so this 3D, it contains 2D as its element. So it contains these things. These are two-dimensional array. The entire two-dimensional array is its element. So you can have that one is the first element, then another one is the other element, and the list continues. And then for four-dimensional array, it goes in that format. I don't have to go up to that. So I don't know if you've understood Ray. Before the dog took your bone. You're still solving the issue. You're still beating the dog. The rest have understood. Am I in the meeting?
Yes, that was clear.
Yes.
Okay, thank you. So Now, I believe Ray understood. If he hasn't understood and the others have understood, we'll explain to him in the group, or maybe we shall share the recording. But now, for example, how do you check? How do you check how do you check the dimension levels? How do you check the how do you check what? How do you check the number of dimensions? How do you know how many dimensions are there? So basically, NumPy arrays provide us the NDIM attribute that returns, an integer that tells us how many dimensions. Sorry, guys. So basically, to check the number of dimension, basically the number, it has an attribute called NDIM attribute, which will return an integer, which tell us how many dimension the array has. So I think I'll try with this one, though you can apply it on the rest. Or perhaps let me try to do this. Let me just create a new cell here. First of all, let me import. Because I remember I'm repeating myself for some beginners to understand, but I remember once you have this thing at the top, you don't have to repeat it again. So let me have 0D. Here's our 0D. And guys, allow me today to use these things, which is not recommended, to use A, B, C, D. So this will be A. Then for two-dimensional array it will be, for one-dimensional array it will be B, because I want to compare all B, and then the other one was 2D first, I guess. This is should be C. Oh, C should be C. Do you have okay, 3D? Let me try to reduce the elements, the number of elements here, so that it can be a bit shorter. What did I say the other time? How do you check the if you are together? How do you check the number of elements, the number of dimensions? Any sharp student there?
You said NDIM?
Yeah, that's wonderful. So let's begin with A, and then a dot, NDIM. Let me do this. Let me just duplicate, and then just change from A to B and so forth. So this will be B, this will be C, and then this one will be D. So let's try. So you can see now the first one, A is, or can I use a string here? Can I use like to illustrate, though I don't want to type by there, let me not go into that direction because I don't want to type. But you understand this A stand for, this one stand for this first one. You can see the output is 0, which means that is a 0-dimensional array. The second one is a 1-dimensional array, which is 1, and then C it is 2, and then D is 3. So guys, I basically use this attribute to check the number of dimensions you have. Now let's try with 4D. Let me try it with 4D, though I don't know if I'll complicate things. np dot, or maybe let me put it this way. Let me try to use I'll try to to interchange so that you can see it's not just a logic here that is printing 1, 2, 3. Let me try. First of all, let me use here. Let me use this is a 2D. Let me just cut. Let me just cut and then I use it here. So that I think you'll understand how these things work. And then here I'll add in and the 4D. So 4D is what? Anybody who has now understand the flow here? Who can tell us the 4D? What is a 4D array? Another bright student? Hmm? Anybody?
An array with 4 levels of nested lists.
Of the nested list. And our symbol is how can you put it in a NumPy context? Because in NumPy we define them as a array, and not. Can you try to put it in a similar?
We can say it has 4 levels of nesting.
Or nesting. Yeah, that's very correct. But in other words, you can just say it is an array element which contains 3D elements. This 3D array is its element. So you just take the entire 3D things, 3D elements, then it will be its elements. So this will be the first elements of that 4D, the second one, and so forth. So here I think I'll say let me add in another one. So this should be E. So that I have just interchanged so that you may not see this is just a logic or 0, 1, 2, 3 and so forth, so that you understand this how these things work. So you can see now the third one is the C is 4D. You can see now it is 4. Then the last one is a 2 dimensional array. Guys, are we together? And first of all, if time is much spent, if you are not understanding, just tell me to stop. Guys, you've understood?
Yes, you have.
All right. So now sometimes you want to create. I just want to create. You just want to create the array elements of whichever number you want. Other than doing it manually, you can just define a method which will automatically create several dimensions that I want to specify. So, for example, first of all, remember before working with NumPy, you must import the module itself. And then here I'll say, let me just use this one-dimensional array. And then we have another attribute called that is called ND, just like this one. Just like this one, but this one it has what it's not even similar. Sorry guys, it is this way. You can see. Let me undo. Let me just use it in our way. So basically, this is the method that you can use to create other to generate other to generate the levels of dimension you want. So let's say you want 10-dimensional arrays, 10-dimensional array. So in this case, you just use this attribute ndmin, and then you'll assign to the number of dimensions you want. Let's say if it's I said 8, I said 10. Let me use a 10, and then remember it's separated with a comma here. And then first of all, let's print what's the spelling for print? I don't know why it's not highlighting. So okay. Oh, was there an indentation? Did I wrote a wrong statement there? Okay. Wow. I am used like oh, okay. Oh, I thought it has to be green. Kumbe it's not always the case, like for it to be green, because I was used to green things. So first of all, let me print out B to see the level of dimensions, and then let me just use here let me type here string, and then type here something here. Let me just use, let me say the number of dimensions are. I could even use the formatted string so that I can use the variable inside, but no problem. And then here I'll add in the comma to separate parameters, and then here I'll say b dot what now to check the number of dimension. Guys, you understand that thing? You can just tell me. Don't want to say everything. If you understood what I taught you earlier. How can I check the level of dimension?
NDIM.
Okay. NDIM like that.
DIM.
I
Yes, yes.
like that. Okay, okay.
Yes, please.
All right. So now you can see it is displaying 10. You can see first of all this is this is a 10D array, and then it contains what it does what it you can see now the output here to display like this one is a 10-dimensional array. So guys, basically you can generate your other arrays, that way. So basically that's how you can, generate the number of dimension you wish. You can even generate 100, 50, or so forth and so forth. So basically that's how you can do that. Can I talk about the NumPy array indexing? By the way, let me know at what time you want me to finish. Or I've passed your time. Your time. All the time that I should stop. For me, I can even talk even up to them to tomorrow. Yeah, and I can talk, and the people perhaps will be sleeping and I'm talking. So let me just note so that I can check on the time there. Or I will stop. Yes.
I know, I think that's you are just in the right timings.
Hmm.
Yeah, I just wanted to ask, maybe
Hmm.
you can call it, it might not appear like a professional way of knowing, the type of the dimension.
Yes, yes.
Now, if you count those square brackets,
Hmm.
you find that they are 10.
Hmm.
If it's two dimension, if you count the square brackets,
Hmm.
that is on one side.
Hmm.
The opening and the closing, both sides are 10, 10. So that's 10 dimension.
Hmm.
For two arrays, for two dimensions, you find that
Hmm.
the opening square brackets are 2 and the closing are 2.
Hmm.
For one dimension, one square bracket.
Hmm.
Yeah, just maybe it's just a by the way.
Oh, but remember this is, I believe we are talking about this outer square bracket, like to identify the number of array, like at the level of dimensions. Because I remember you can have, this is a 10D, a 10-dimensional array, you can say that is an array element that contains a 9-dimensional array as its array element. Let me put it somewhere, because when you use it inside, it will be, let me say here f, and then I'll assign here to np dot should be array. So basically this is a 10D, but now this 10D, it only contains one element of the 9-dimensional array. So you can have several of the 9-dimensional array. You can have even the other here like that. So you can see now when it is inside, it won't be 10, it will be 9. 1, because a 10-dimensional array, I said, is an array element which contains 9-dimensional array as its array element. So if you are counting in the inside, it will be 9. It will be 9. 1, 2, 3, 4, 5, 6, 7, 8, 8, 9. But if you count on the outer, it will be 10. So basically, if you want to check like the way you are proposing, you were to like count the outer. Like if you want to know, you count the outer. But now I said, to simply put, you can say it is an array that contains 9-dimensional array as its array element. So the inside element should be the 9-dimensional array. Is that clear?
Yes, yes, that is very clear. Yeah, so I was saying you just count the outer brackets.
Yeah.
The outer square brackets in the beginning or even at the end.
Yeah. That's very correct. Now the inside is a 9, because a 10-dimensional array contains now the 9-dimensional array as its array element.
Sure.
Yeah, and that's fine. Now, perhaps will you allow me to talk about the indexing? Then I'll release you. How you can access the elements in an array.
Yes, that's okay.
Okay. So let me just use a simple one. I don't want to complicate things so that the people can forget everything that I've just spoken here all this time. Let me just use a simple one so that you cannot forget things. So here, let me just use our normal variable array, and then just to simply insist on importing the modules. Yeah, that way. Now, basically, to access the element, the way you used to access the elements inside a normal list is just the same way here. So, for example, if you want to access the first element, it will be what? Who can guess? Which index will it be if you want to access the first element of this one-dimensional array?
0.
It will be 0. That's correct. So you first of all pass in the array. So this is the object, and then at the index that you want to return. Remember, when you just run this array, it will return, everything. But if you want to return a particular element, you have to specify. You have to specify the index. So, for example, if you want to access index 0, it will be the first element. So it will return the first element of this one-dimensional array. So if it were let me try with something like a 3. 3, we all know it will be 4. It should return 4. So when I run, you can see it's 4. The same way you can do the same thing with, I don't know if people will be confused, but let me try with the 2-dimensional array. So for a 2-dimensional array, when I say, for example, 1, it will return. So when I use like a 2-dimensional array, and then here I pass here 1, who can guess which elements will be returned?
I think it will return 1, 2, 3. Oh, sorry. 5, 6, 7, 8.
Yeah, that's very true. That's very true. You can see it is 5, 6, 7, 8. And then the same goes to the 3-dimensional. Let me try that one. And let me say it will be the last one. I don't know. I usually say that is the last one, then I add in another. But now this one, for real. This is the last one for 3D. If someone will get this one correct, what should I give them? Let me not promise anything at the moment. So now, for example, if you want to access the index 1 elements, which one will that be on this 3D? First of all, this is it only contains one element. Sorry, guys. Let me try to add in. Someone wanted to answer and it was wrong. It will return by there. Let's try to run first of all. It will throw an error. It should. You can see it throws an error because it only contains one element, and then here we have defined the index 2. It only contains index 0. So I should have added here, and then perhaps I can change here to, let's just say 100, 200, 400, and then here let me use 50, 70, 70 what, 90, and so forth. So this way it should work. Oh, by the way, the other thing about it should have the same number of
elements.
Yeah, that's the other thing that I should note. And that's the bad thing or the good thing with the NumPy. So let me use 300. Now here I'll add in 100. So you can see now it is returning the second one, but I forgot I should have given you as an assignment. So guys, when I use here 0, when I use 0, which elements will be returned? Any other person?
So 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8.
Yeah, this one.
1, 2, 3, yes.
Yeah, that's correct. That's very, very correct. So it returns this. So basically, guys, this is how you access the elements. And so, guys, I don't want to give you a lot because I might not capture.
Sorry, just a question.
Yes.
Even though this list have commas, why are they still represented as one element or one row in the array? Even though there are three lists there.
The same way, I think the key thing here is to understand this when I talk about, for example, one-dimensional array, two-dimensional array. First of all, once you understand the definition of that, I think you'll understand it well. So let me simply put it this way. For example, if it's a two-dimensional array, it will contain one-dimensional array as its element, and you all know how a one-dimensional array looks like. So basically, this is a one-dimensional array. Is an array with just one list, one list. But now, and then now we can see here in this one-dimensional array, it contains the zero-dimensional array as its element. So when you go to the two-dimensional array, you'll have an array list. You know how to define an array list, or basically how to define an array. We just use the square brackets, and then after you define that square bracket, you'll have this one-dimensional array as its array element. So this will be like the one. If you use it direct, it will be the one-dimensional array. Then when you add in another like this, it will be, now this is a example of a two-dimensional array. So you have, this is a one-dimensional array, another one-dimensional array, another one-dimensional array. So this is a two-dimensional array. So it's an array that contains one-dimensional array as its array elements. So when you go to the to the three-dimensional array, it will contain the entire of the two-dimensional array as its array elements. That's why you'll count it as one. So it contains for three-dimensional array, it contains the entire two-dimensional array. It will be like for its one-dimensional array, it will be like a one element of a three-dimensional array. That you can have several of the two-dimensional array. Are you lost still?
You can go on.
You've understood?
I'll catch up as it goes on.
I think I don't know. You guys, you still have energy. I continue. You know, in the modules, where did they cover up to? Because I saw it's like they just provided small content, and NumPy is so broad. In fact, it's a one-man thing. I don't know where they reached in the content. I didn't finish. Where did they cover on NumPy?
functions in NumPy.
There's
Yes?
so slicing.
Slicing. They
Yes.
talked about the slicing.
Yes.
Should I cover it today so that we may like? But NumPy is so broad. It's so broad. Can you allow me to cover the slicing?
Yes. Yes.
And the rest? How many are we there? Or we are just three people and I'm asking the rest?
Yes, you can cover.
We have a lot of people here. Yeah. So let me just try to cover what is provided in the content so that you can know how to answer the question in case they ask questions there. But I want to inform you that NumPy is so broad, so broad. But I know we shall learn it as we continue. Now, basically, slicing in Python generally just the same way we understood in the list. So slicing in Python, it means like to take elements from one given index to another. For example, you want to return some elements from a particular like you don't want to return all the elements, you just want to return particular portion of elements. So you can specify the the start tag, the start position, and then at the end of the position where you want to have. And then should I show, let me just show you an example so that you can relate, because I think when I talk, people won't understand, especially at this time. Let me just do it practically so that you know what I'm talking about. So let me just use a simple one for a 1D array. This is a lot of white space. Let me just use it here. My work should be neat. And guys, you understood that it is a good practice to always use the descriptive name when you are defining the variables, not ABCD like the way I used at the other side. So it should be descriptive. Now, as I said, basically let me just write here syntax here at the bottom. So basically, this is how you can slice. Remember, we are slicing the list. So a list is defined with this as square. So you have the start, start of the slicer. Is it the scissors, where the scissors begins to cut, and then at the end. So we can also define the step. Like for example, you want to skip some portion and then I continue to the rest. Let me not talk about that. Let's finish this one first of all. So basically, when you are doing the slicing, you define first of all the start, and then the end. So basically, this is the syntax. So let me delete, and then I show you in action. So let's print. Let's print, and then here we are passing the array the same way we used to slice the list. It's just the same way. Remember, the NumPy array are just like the Python list, only that the Python list can contain several data types, but the NumPy array will only contain. By the way, guys, I didn't show you that. Let's try to add in here a string. Let's try to add in a string here so that you can tell I'm not sio stories za Java. So let me add here 7, and then okay, let me try to use let me say Nehemiah. I don't know if it will work or not. What? It's working. It's working, but guys, when you're working with the NumPy array, you shouldn't like mix what you shouldn't mix like there's a way it could throw an error. I think I'll do a research on that and then I'll tell you.
Nehemiah,
Yes.
Nehemiah,
Yes.
print this one now. Just print this one like this.
To print
Run
what?
this cell now. Just run this cell like this now first.
Or this one?
Yeah. So what happened was that
Hmm.
it contains only one data type, but immediately you put a string, it converted all the other numbers to
Oh,
string.
yeah, sure. By the way, I've just noticed that as well when you've just spoken. Yeah, guys, by the way, let's, and then I guess the good thing, let's do this. Let's try to print the type, right? Let's try to print the type so that we can change, we can check. We can check. We can check. So you can see now, it is an ND array. Let me try to add in the other thing. Hi.
It will still be an ND array. Remember
Because
that
yeah.
an array
Mm.
contains a single type of data structure,
Oh,
right?
so basically,
So it doesn't matter.
mm.
Yes. So you
So
want
it
to find
converted
what
everything to strings.
exactly. So you want to find if you are looking for the type, you are trying to find the type of the element inside
Mm.
the array, not the
Mm.
type of the array. The type of the
Mm.
array will always remain ND array.
Mm.
So unless you want to find the element, the type of the element inside the array.
Oh, yeah, sure, sure. So we remember when we introduced NumPy, we said that we create the ND array object with this array function. So that's why it will automatically return this ND array here as the data type. But now when you just print here like this, sorry, I should have deleted the other ones. When you just print it this way, you can see the output is now strings. But now when you just remove these 7 here, it will be the integers. So guys, you can tell that NumPy doesn't allow you to work with several different, data types. So you can just use you just use what? You just use okay, I'm so tired. I don't know how can I put it. So basically, you can just use a single data type. You can just use a single data type. Yeah. So if it's just string, it's string. If it's integers, it is integers. Otherwise, it won't give you the results that you'll want. Now on this one, I was talking about the slicing. So to slice elements, so let's say you want to return from index number 3 to the end, you'll just use what? You'll just use, for example, index number 2. This 2 should be 1. Should be 1. And then, for example, you want to return from number 1 to the end, so it will return from this to the end. So let me return. So you can see it returns from 2 to the end. And then you can specify, for example, you want to return, let's say, from number 2 to number 3 to index number 3, that should be 4. You just specify the end. It will be to number 4. And then if you wanted like to return maybe from number 4 onwards, you can just leave it this way. Then it will return everything up to the index number 4. So guys, I believe you understand, and you can as well use the same when working with other dimensional array elements. I think, and as well you can do the negative slicing. Hmm?
Nehemiah,
Yes, yes.
that thing we're trying to do, can you
Hmm.
just try if we can do it here? You know, this that slicing you did,
Hmm.
we understand it. Can you maybe either you just try and copy that cell or
Hmm.
maybe just post beside the array the DT type
Hmm.
to find the data type inside the array. Print array.dt type.
I'm not understanding. Is it on the slicing still?
No, what you did before the slicing is what I was saying.
Oh,
You know,
you
you're
say
trying
use
to
a different.
show us,
Hmm.
yeah,
Oh, oh yeah.
you know, you're trying to show us something
Yeah,
about,
I was trying to explain that NumPy only allows you to work with. It is homogeneous. It allows you like to work with
yes,
only a particular data type. If it's integers, it is integer. If it's string, it is string.
yes.
So
So
what did you want me to?
I was saying that you should just put array array.dt type to help us see that it contains a particular data type, what we were trying to do earlier. So print array.dt type will help us see the type of data structure in the array, whether
Dot
it's a
data type.
string, whether it's an integer.
The dot data type. Like there.
Let me look at it. DT
I
type,
don't
yeah.
think I don't
D,
think it has. Or if you just want to
I
return
think
the type, you can
it
just
will
type
be
there
before
no,
array.
different
DT,
It should be
DT,
before
DT,
array.
DT, no,
or
no,
DT
no,
like that.
delete the type. DT, yes, like that,
Okay.
like
Uh,
that. Yeah. Then put bracket, yeah, exactly.
oh, so let's try with 7. Not 7 actually, with a string. So it is returning now. It is returning a string. Remember, we have different types of strings. And then I think this one yeah, this is part of a string. This is part of a string still. So guys, you realize that on NumPy you can't work with different data type at the same.
So, Nehemiah, please can you do 2D slicing? Yeah,
We do the slicing.
2D, yeah,
Pardon?
2D
2D slicing.
on slicing on 2D,
Oh,
3D.
okay. Let me first of all to be organized. Let me try to push that one at the top. Then let me get the 2D I had written because I don't like repeating, not typing. So where is our 2D? Here it is. This one. Array says a good practice to be descriptive when defining your objects, and then NP about. Let me just copy. No, there's no harm. Okay, so you wanted me to show you how you can slice on a 2D. Print. Yeah, print. I used to think that this print function should be green like the rest of its friends, but it's not green. So now to slice the elements. So let's say you want to slice up to number. Let's say you want to slice from index 1 to the end. So you'll begin with the object, and then it will be what you want us to slice what here, for example, to be different. Let me see, 9, 10, 11, 13. Are you there?
Yes.
There's someone who asked. I don't know if she's there. I want to interact with her so that she understands. Or she went to sleep again. So essentially, these are the elements. These are the elements in a 2D. These are the elements. So the same way we were, like slicing elements in a 1D, like these are the elements in a one-dimensional array. So the same way these are the elements in a two-dimensional array. So when you are slicing, it means that you only want to return, specific parts of the elements. So it's just the same approach. So let's say we want to slice which let's say 0 to what? So this is the start 0, index 0 to 1, index 0 to 1. So you can see it will return that one. Let's try with index. Let me just say index index 1 onward. So you can see it returns that index, remember it always like if you're using if you're defining the other the end, it will skip the first one the same way it used to do with our Python list. You just skip the last item that you've defined, so it will skip that one. It won't print, so it will print from that one to backward. Yeah. So for example, let me say now, let's say we have here index 1, 2, and then 3. So if you want to return these two, index 0 and 1, you'll use 2. So it won't print index 2. It won't print index 2. It will. Let's see first of all. So you can see it skips this index. So it always skip the end element that you specified. Then it will return the previous. But now if you are returning, you are using the start. Start usually begin with the first element that you've defined. But now it won't print out the last element that you've specified. Yeah. And remember, you can as well do the negative slicing the way we used to with the list. You can as well do the negative slicing. By the way, did she understood? I don't know why she asked and then she went away.
Yeah, I'm here. I understand.
You've understood?
Yeah.
Yeah.
But there's one that I saw that made the the element instead of maybe 3 by 2, you now have 2 by 2. So I'm trying to understand that aspect. That when you slice this array now, you
Mm.
now get instead of 3 by 3 or something, or 3 by 4, you
Mm.
get 2 by 2 or something, like a 2 by 2 matrix. I don't know if you understand what I'm trying to say. I think I have the same question. Maybe I can ask it. I understand Shikona. What she's trying to ask is,
Yeah.
what if we want to get, for example,
Mm.
2 and 3
Mm.
and 6 and 7? How will we print?
2 and then 2
Two,
element 2.
three on the first list,
Mm.
and then 6 and 7 on the second list.
So I think
We want
that's
to get,
mm.
yeah, we want to get
Something like
those,
that.
yeah.
Oh. Can I, because there's something that I had to cover before I talk about it so that I may not confuse people. Can I just maybe discuss on that? Maybe there are some things that I had to cover before I talk about that because I know I might confuse the rest when I talk about that at the moment. Because can we just do it in so that for the interest of others, to show you so that I can show you, for example, how you can return particular elements from to return some specific you I think the question is to try to return specific elements within, for example, you want to return only some parts of this element and then the other part of this one, like that, right? That was the question.
Yes.
I think for the interest of others, I think I will recommend I will go from bottom to bottom up so that people can grasp everything. I think by today people should just understand what I've maybe perhaps taught at the moment, so that I may not confuse others. You guys are sharp. You guys are sharp, but for the interest of the rest, I don't want to congest things on the same. However, I can just show you on your inbox. If you inbox me, I'll show you. But for the rest, I don't want to confuse others. Yeah, so you can just capture or catch what I've taught the rest of the people. And then perhaps tomorrow, because pandas just build up on on NumPy. So Panda is not that complicated with Python. So I think tomorrow we can just do a simple one.
Nehemiah,
Yes, yes.
don't you think it will also be kind of beneficial maybe if you just highlight it? So that
To
even, those ones who cannot reach your inbox can.
no, I'll explain still. I'll explain in our next meetup.
Okay.
I'll explain everything.
Okay.
Yes, yes. Yeah. So guys, I believe for people to understand well what we've discussed today, I think we should stop there, because when I'll go further, you might forget the rest. Though we have the negative slicing, in fact, I don't want to touch on that. I don't want people to get much more confused. But I believe you understand the basics of NumPy. The basics of NumPy. And we have a lot here. I just wrote down some topics to cover on NumPy. We have, for example, if you want to reshape, you want to reshape a particular dimensional array to a different one, or maybe you want to create a view from an original array. You want to create a view, or you want to create a copy, or maybe you want to iterate, or maybe you want to join, or you want to split. And the other means many things that I should have talked about on this NumPy. In fact, we also have another powerful module on NumPy still, another module called random as well. There's a lot to discuss there. And then we also have the NumPy universal functions as well. There's a lot to talk about there, and many other things. But I think we shall create time step by step, just step by step. Then but I tend to think the Explore team will try to create another content, because I don't believe that should be the end of NumPy, because it's so big. NumPy is what machine learning is all about. NumPy covers a lot in data science. So let me just assume that they'll add in more content on the same. But we shall, in case they don't do that, we shall just learn by ourselves. Yeah. So yeah. So guys, basically there are things that I'll try to explain tomorrow before I talk about that one, so that I may bring everyone on board. Yeah. So guys, I think this is what I had on my end. Unless you have a question based on what I've covered today. Have you guys understood any other person apart from those who are, apart from our genius guys here who have spoke here, the Ray, Ian, Ibrahim, Lauren, and who? Any other people apart from those that I've mentioned? Have you understood? No, there's another girl from Nigeria. I've forgotten the name. She also, um, she was. I don't know if other people have understood things. Or, yeah, thank you. Thank you so much for confirming. So, if there's no question, I think I'll return it to the moderator. Let's stop.